Okay, so I needed you to understand, because we have perpendicular bisectors, that H was the circumcenter. That theorem states that it's equidistance from the vertices. I went ahead and marked it for you. 19 basically is going to equal to 6x minus 5. You just needed to solve for x. Hopefully we got x is what? 4. And then they wanted us to find EH, so just basically we should already know that. Because, oh no, they didn't want us to find H. It's just the x. That's the last one. All right, and then here we saw that this is a perpendicular bisector, so that means G is the midpoint, and the segments, the side EF gets bisected, so EG is going to be congruent to FG. So hopefully we had 3Y. Most of you already did this. When I was checking, we had a good percentage on correct answers. And then you solve for Y. I would accept, some of you wrote 7/2. That's acceptable, okay? Or, 15/2, sorry. Which was 7.5. Okay, there we go. Okay. So either or. And then the last part was talking about the angle EGH. EGH would be 90 degrees because of the perpendicular bisector. Perpendicular means we have 90 degrees. So the 9Z needed to equal to 90, which was 10. Z was 10. All right, so that we're done with part A. We are going to part B. So I need you to put your part A away. We're going to finish the part B in class, the examples, and get to some practice problems. All right, so part B. Okay. Part B, I explained on the video after the construction what each one was. You need to know what a median is, its characteristics, so you can identify, and I'm going to talk about markings you must see. So a median, segments whose endpoints are a vertex of a triangle and the midpoints, and I'm going to abbreviate that, of the opposite side. So if I was starting with the vertex B, okay, I'm just going to guesstimate. To draw the median, I would need to go from the vertex to the midpoint of the opposite side. So I have to see tick marks. If you do not see tick marks, then you're not dealing with medians. So you have to be familiar with the markings that pretty much give you an indicator of what special segment you're dealing with. All right, so the centroid is the point of concurrency for the medians. And we're going to use the centroid theorem, which basically just says that if I had, and I'll show you up here, when you did your constructions, I believe you had something similar to this when you were done, all the tick marks. Yes? All right, hold on. Okay, P right here is the intersection of all the medians. My blue lines are my medians in my illustration right here. What I want you to understand, I'm going to just focus on one median, and let's focus on just this one right here, okay? I think on your patty paper you had what? This was B. Was this A? It was C, then A. Okay. And then let's say this is the midpoint. Okay, M. All right, so I think if you look at it, you can physically see that BP is bigger than PM, right? Okay, now the theorem says, the centroid theorem says that the distance from B to that centroid, that's the P, is 2/3, okay, from the vertex. So if that's 2/3, then the remaining part here would have to be 1/3. Okay, so that is basically our centroid theorem. The location of the centroid is 2/3 of the distance from a vertex to that midpoint of the opposite side. Okay. Now, 2/3. Oh, I wrote 1/2. 2/3. 2/3. Okay, here's what I'm going to do. Here's what I want you to recognize. We got a big part, small part. If this is 2/3, then the whole thing is one whole, right? So they have the common denominator of 3. So I can just break it down to a ratio of 2 to 1. And if we do that, then we have to worry about fractions. And so the centroid theorem has the same relationship of a ratio of 2 to 1. Okay, and that's how we're going to find our answers, using that relationship. So we're going to do 2 to 1, and we're going to practice that right now. On our examples, okay, I'm going to go to an easy one first. So let's do the practice problems here. We got, says point T is the centroid. I'm going to label each part here. CT is 6, so I'm going to do that little part there is 6. TJ, that's a big part, that's 20. And then we have KB, which is the whole median, is 33, okay? Now, when I look at the relationship, I'm staying on the same median. I'm not going to mix them up. So I'm going to start with CT. CT is on the medium CL, okay? So think about this. Remember the ratio is 2 to 1? So this would be 12. That, think about it. Just double it. Double the 6, that would be 12. So TL is 12. We got that done, okay? Now, AJ, use that same relationship. What would AJ have to be? So close, so close, so close. 30. How do we get to the 30? Yeah, AJ is the whole median, right? We know TJ is 20, so yeah, 10 is the AT. So you were right about the relationship, but where you put it was wrong, okay? And then the whole thing would be the 10 plus the 20, which is 30. Okay on that? All right, now we're looking at TB. They want us to find TB. That's our small part here. But we know that the whole median, which segment is the whole median? KB. KB is 33. All right, remember it gets broken up to 2 to 1. So how can we figure out the distance of each one? The little one, yeah, is 11. So this would have to be 22, and then together it's 33. Are we okay on that? All right, so you'll start seeing a pattern here. Yeah, TB is 11. Sorry, I forgot to put that there. All right, so on this example here, now we're going to add a couple variables, but we're going to use the same relationship. And there's going to be more than one way to answer it. That's why I want to talk about it. Yes? It's always going to be 2 to 1. Like, oh, okay. Yeah, you can see it. So, like, if I'm looking at, let's say I'm looking at this median here. Do you see this part from A to P is the bigger part compared to, huh? Yeah, because that's the ratio. It's always 2 to 1. So you should be able to see, you should be able to associate the 2 distance being greater than the 1 distance. Yeah, okay. All right. All right, so here we go. D is the centroid. They want us to find X. X, the variable X, is on what median? Yeah, B to G. Okay, so that's what we're going to find. Where is our 2 to 1 on B to G? 24 and the 6X. Okay, so how are we going to solve for X? You could do 1/3 of 24 to get to 6X, yes? Or we could do, instead of using the third or the 2/3, we do 2 to 1. So this 2 of the 6X will equal 24, or 6X would equal 12. Yeah, because it's 2 to 1. So if I half the 24, that would be my 1. So X is 2. Yep. All right, let's do Y. We're doing 8Y and 32. What do we know about those relationships? So I could do 8Y times 2 equals 32, or, yeah, or 8Y just equals 16, right? Y is 2 again. No. All right, try the Z. So we go 9Z plus 6, and we have 6Z. So how can I set this one up? 2 times 6Z. I know, I did. Because then you would have stopped, and you would have just said they're all 2, and then you wouldn't do anything else. Okay. All right, do the last one, which is the one at the top. We have 6 as our 2, and we have 2x minus 5 as our 1. 2 to 1. See if you can do this one. I'm going to let you. All right, either way, x equals 4. No? Or what is it? X equals 4. Mm-hmm. X equals 4. Like, which way you want to do it? Okay. 4x minus 10 equals 16. I mean, equals 6. And then when you add the 6, it's 16. So add the 10. 4x equals 16. So x equals 4 here. This would be 2x equals 8. And then x equals 4. Okay, either way. All right, and then the last one, altitude. Okay, let's talk about that real quick. Altitude is a segment from a vertex. Okay, again, we're going to go from a vertex to a line containing the opposite side, and it's perpendicular to that line containing the opposite side. So vertex and perpendicular, meaning I need to make sure I go from a vertex to the opposite side, and I must see the box to show that it's perpendicular. So on your constructions, when you're looking at an altitude, all we should be seeing are the right angle symbols, the box. That's it, to know it's an altitude, okay? Now, the second part is the orthocenter. That's the intersection point of the altitudes. So here, the last part was one we need to make sure we know the difference between a median and altitude, and then can we identify the orthocenter. So on this next little section, it says, is the MN a median, altitude, or neither? Explain, okay? Kind of ask yourself, MM is blank the side of the triangle and its intersect. So number 1, what would it be? Yeah, 1 is a median. How do I know that? Tick marks, yes. Median, because we see those tick marks, we know this is a midpoint. Okay? What about 2? It's an angle bisector, yeah. Okay? So this would be neither. For this situation, okay? What? I'm going to let you try 3. Write it down when you think you have an answer. Just write it down based on what's marked and given. MN is an altitude. How do I know that? Because all I see is a right angle. And it's going from the vertex to the opposite side, and that's where the right angle is formed. All right, so on the last part here, we're going to use our medians, use our relationship with altitudes, and then pick our orthocenter. All right, last page. Find x, and RT is RT. If SU is a median, we want to find x. So we're talking about median, guys. So what do I know? Yeah, they're both equal here. TU is going to be equal to UR. So we start off with this. 2x plus 24 is equal to 5x minus 30. And we're going to solve for x. Yeah. Yeah. We should have 18. Yeah. X is 18. Okay. Now, it says, is SU also an altitude? How do I know it's an altitude? What do I need to know? Yeah, perpendicular. So I need to know 90 degrees. So we need to know, would it make 90 degrees? So basically, we're going to plug this in. 4x, or 4 times 18 plus 18. It equals 90. So this is yes. It's an altitude also. So on the example 5, now they're telling me that HK is an altitude. Okay? Back to altitudes. What's so special about altitude? 90 degrees. So that means, yeah, the 3x, that's where I need to focus on. The 3x plus 3 equals 90. I don't use the sides. I don't use the segments. Divide. What? Huh? Yep. And then the last part. All right. Last part. They want us to find which point would be the orthocenter, guys. The orthocenter is created by altitudes intersecting. So on the first figure, it is H. Good job. Because this would be the altitude, and then that would be the altitude. So H is the orthocenter. See, just write it down. See if you can get the next one. Where the orthocenter, just write it down. The altitudes are the lines that are perpendicular. Yeah. Yeah. Have to intersect. All right. What did we get on 7? Yeah. Y. It's Y.